Modern science says the sun is the past, the earth is the present, and the moon is the future. From an incandescent mass, we have originated, and into a frozen mass we shall turn. Merciless is the law of nature, and rapidly and irresistibly we are drawn to our doom. We are WHU Explorers. Today we are going to share some facts about space that will both terrify and amaze you. Number 1. The speed of light. Everybody loves to imagine themselves flying through the galaxy at the speed of light at roughly 299,792,458 meters per second. However, the reality might be less fun and a lot more fatal. When coming into contact with an object moving at light speed, hydrogen atoms transform into intensely radioactive particles that could easily wipe out the crew of a starship and destroy electronics in seconds. Just a few stray wisps of hydrogen gas floating through the cosmos could have a radioactive output equivalent to a proton beam created by the Large Hadron Collider. Number 2. The Moon. Every year our Moon gets about 4 centimeters farther away from the Earth. And while this might not seem like much, at first, it could have devastating effects on our planet in the future. Although the Earth's gravitational field should be enough to keep the Moon from spiraling into space for good, the increasing distance between it and the Earth will eventually slow our planet's rotation down to the point where a single day will take longer than a month. And our ocean's tides are locked in place. Number 3. Black holes. Typically formed out of the death of massive stars, black holes are super-dense regions of space with so much gravitational pull that they trap light and warp time. Just a small black hole in our solar system would throw planets out of orbit and tear our sun to pieces. If that wasn't scary enough on its own, black holes can hurtle across the galaxy at several million miles per second, leaving trails of destruction in their wake. Number 4. Gamma rays. The most powerful type of explosion in the universe, gamma ray bursts, are intense high-frequency bursts of electromagnetic radiation. They carry as much energy in milliseconds as our sun will give off in its entire lifespan. If one of these rays were to hit Earth, it could strip the atmosphere of ozone in seconds. And some scientists even attribute a mass extinction 440 million years ago to gamma ray bursts hitting Earth. Number 5. Zero gravity. Scientifically referred to as microgravity, this condition occurs when an object is in a state of free fall and appears weightless. Although it may look like fun to float around like astronauts for a prolonged time in zero gravity conditions, can have long-term mental and physical effects on humans. Number 6. Cold welding. Here on Earth, gases in the atmosphere react with metals to create a thin layer of oxidization. The vacuum of space, however, has no atmosphere and therefore causes no oxidation to form on metals, leading to an interesting reaction. This reaction is called cold welding, and it occurs when two metals of the same molecular makeup are pressed together and fused together permanently as if they were one piece. While this may sound neat, it caused quite a few problems on the first satellites and can make in-space repairs very tricky. Number 7. Alien life. The universe is massive and unbelievably old, so the chances of other planets similar to Earth evolving life is not unlikely at all. According to Fermi's paradox, the high probability of extraterrestrial life out in space is contradictory to the lack of apparent evidence supporting it. At this point, we aren't sure which is scarier, the fact that we might not be alone in the universe or the possibility that we are. Number 8. Rogue planets. Launched into space after the formation of their planetary system, rogue planets are planetary bodies. They're free to run the cosmos, crashing into things as they go because they do not orbit the sun. Rogue planets often have freezing surface temperatures, however, due to their molten cores and icy insulation. Some scientists theorize that these free-roaming planets could contain massive subterranean oceans that support life. Number 9. Travel times. In 1969, it took the Apollo 11 lunar module 3 days to land on our own natural satellite, the Moon. Since then, our technology has increased rapidly, and we could expect to reach Mars in 7 to 9 months, and reaching Pluto would only take about 10 years. Distances outside of our solar system become even more extreme. Even traveling at the speed of light, it would take us over 4 years to reach the nearest star, Alpha Centauri, and over 100,000 years to reach the galactic center of the Milky Way. Number 10. Extreme temperatures. Depending on where you are in space, chances are you're going to find yourself in some pretty extreme conditions. The heat put off by a supernova can reach temperatures of 50 million degrees Celsius or more, 5 times that of a nuclear explosion on the opposite end of the spectrum. The cosmic background temperature of space measures minus 270 degrees Celsius, just slightly warmer than absolute zero. You definitely won't want to forget your jacket. Number 11. The darkness. Being scared of the dark isn't just a silly thing that children experience, it's an evolutionary trait humans developed to protect themselves from dangers lurking in the unknown. The only reason adults nowadays don't fear what they can't see is because they have learned through experience that the likelihood of monsters hiding under the bed is very low. In space, however, darkness represents a completely unexplored emptiness that continues for an infinity. So being afraid of the dangers that lurk beyond our sights is a completely understandable reaction. Number 12. Magnetars. Magnetars are incredibly dense neutron stars. In fact, they're basically an entire star crushed into a sphere only 15 miles across. 1 teaspoon worth of magnetar contains the same mass as 900 Great Pyramids of Giza. They are also the hosts of the strongest magnetic fields in the known universe, fields so strong that anything that gets too close is ripped apart at the atomic level. Number 13. Musculoskeletal atrophy. Maintaining a healthy level of exercise is hard enough here on Earth, but in the zero-gravity conditions of space, it can be even harder. Astronauts visiting the International Space Station have exhibited signs of significant muscle atrophy after only 6 weeks in space, and that's with a rigorous health and fitness program. Number 14. Venus. Despite getting its name from the Roman goddess of love, Venus is perhaps the most hellish planet in our solar system. With surface temperatures of nearly 500 degrees Celsius, atmospheric pressure 90 times that of Earth, and constant sulfuric acid rain, simply landing on Venus would kill you in moments. This definitely isn't a planet you'd want to have a picnic on. Number 15. Dark matter / dark energy. We know very little about our universe. In fact, we've only seen less than 5% of the stuff that it's made of. The other 95% is dark matter and dark energy. About 1/4 of the universe is made up of dark matter mass that we can't see or find in space but must be there due to its effects on the behavior of its surroundings. The rest of the universe is dark energy, the true nature of which is mostly unknown. However, we're pretty sure that it plays a crucial role in the expansion of the universe. Number 16. Background radiation. The Earth's atmosphere and magnetic field protect us from some really nasty stuff, namely radiation. Cosmic rays, solar winds, and electromagnetic particles permeate the universe so much so that astronauts traveling between Earth and Mars would receive full-body CT scans worth of radiation every 5 to 6 days. Any that didn't succumb to radiation sickness before reaching their target would almost certainly develop severe cancer in their lifetime. Number 17. The expanding sun. Our sun is constantly using nuclear fusion to combine hydrogen and helium together in order to keep itself burning. However, its hydrogen is not infinite, and as it gets used up, the sun will get hotter and hotter. Eventually, it'll get so hot that the Earth's atmosphere will be burned away and our oceans will boil and evaporate completely. Then once all the sun's hydrogen is gone, it will expand outward into a red giant, consuming the Earth once and for all. Number 18. Hypernova. With 100 times more energy than a standard supernova, hypernovae is powerful explosions that occur upon the death of a massive star. Although the factors that cause a star to go hypernova are widely disputed, we do know that the result is often a black hole or neutron star. Number 19. Electromagnetic vibrations. Space is practically a perfect vacuum, meaning that you can count on the fact that your ears won't be picking up any sound while you're outside your shuttle. While the thought of complete silence might be maddening on its own, don't believe that just because you can't hear anything, that there isn't any sound due to the lack of gases for them to travel through. Sound waves are not present out in space, but sounds are still transmitted in space via electromagnetic vibrations. NASA recorded some of these vibrations from select celestial bodies in our solar system and played them back, resulting in some truly chilling sci-fi horror effects. Number 20. Horror effects. Everything can kill you in space. There is no room for error. Even the smallest mistake can and will kill you. Out of the 430 humans we have sent into space, 18 never made it home. Advancements in technology have made space flights today much safer than they used to be in the 1970s. Nearly 30% of people who went into space died. However, the furthest we have traveled is our moon. A trip to Mars would increase the risk tenfold, and going beyond is still far beyond our capabilities. Number 21. Time dilation. Imagine an astronaut traveling through space at speeds near that of light. Now imagine a person standing on Earth. According to Einstein's theory of special relativity, the astronaut will experience time much slower than the stationary person, although neither will perceive any difference in the time passing around them. When the astronaut finally returns home, even if it's been many years on Earth since he left, he will have only aged a fraction of that time. This is known as time dilation. Although we have yet to develop technology that allows us to move humans at speeds fast enough to notice its effects. Number 22. Hypervelocity stars. Thought to be the result of a close encounter with a black hole, hypervelocity stars are stars that have been ejected from their systems and sent rocketing through intergalactic space at speeds up to 2 million miles per hour. Although most of the hypervelocity stars we've identified so far are of similar size and mass as the Sun, they can theoretically be of any size and reach even more incredible speeds. Number 23. Solar flares. Despite the occasional sunburn, our sun has provided us with warmth and light for billions of years. However, don't let our local star fool you. Our sun is a vast miasma of incandescent plasma that can shoot out massive bursts of solar radiation at random. Although they are unlikely to directly endanger any of the life on Earth, these solar flares can create electromagnetic pulses that wipe out power grids, interfere with radio communications, and render technology. Number 24. Depressurization. There is no air in space, obviously. However, that implies more danger than just having to hold your breath for a long time. The human body is adapted to the atmospheric pressure on Earth, which is why when you go up in an airplane or travel over mountain roads, you might experience a popping in your ears in the vacuum of space. There is no air pressure. Within moments of stepping outside your spaceship, all of the water in your body would boil and evaporate, expanding rapidly until you pop like an overfilled balloon. Number 25. The Big Crunch. / Big Rip. Everything must come to an end, but will there be an end to everything? Scientists agree that there will most likely be a determinate end to the universe, but how it will happen is still uncertain. One prevailing theory states that there will be a big crunch in which the gravitational forces of the universe will reach their limit and cause the entire universe to cease expanding and fold back in on itself, eventually converging into a single infinitely tiny point before disappearing into nothingness. Another theory, known as the Big Rip, states that the universe will expand to the point that gravity loses all meaning and the cosmos literally falls apart. Even the particles in atoms eventually float away from each other. I honestly can't decide which is more terrifying. Enjoying the facts we shared? Make sure to click that subscribe button so you don't miss out on new ones. Share them with your friends and help us consistently conciliate curiosity.